Today we will be discussing superdosing Natuphos E 5000G phytase and its effects on nursery pig performance. Phytase is an enzyme that's commonly added to swine diets to help make phosphorus that's bound up in the form of phytate available to pigs. As we do this, we're able to reduce the amount of inorganic phosphorus added into the diet and help reduce the amount of phosphorus that's excreted by the pig. Now, how phytase works is that it catalyzes the stepwise removal of phosphates from phytate or phytic acid, and thus it helps to improve the available phosphorus in swine diets. Now, a previous study that I also presented, abstract number 87, demonstrated a linear increase in growth performance and bone ash values up to 1,000 FTUs per kilogram when using Natuphos E 5000G. The idea of superdosing phytase is the concept of supplying phytase concentrations above that would be needed for adequate phosphorus release to meet the phosphorus requirements. Thus, the idea being that it's used for non-phosphorus related benefits coming from improved digestibility of energy, amino acids, and other minerals in the feed. So the objective of this study was to evaluate the effects of superdosing Natuphos E 5000G on nursery pig performance and bone ash values. In this study, we used a total of 360 barrows that were initially 5.9 kilograms. They were used in a 42-day growth study. Pigs were randomly allotted to pens at weaning across 2 identical barns. Then, pens of pigs were randomly allotted to one of the 8 dietary treatments, which were fed in 3 phases. We had 5 pigs per pen and 9 pens, or replication, per treatment. Additionally, pigs and feeders were weighed every 7 days to track growth performance and feed intake. In this experiment, first we had a negative control. The negative control was formulated to be the positive control minus the phosphorus and calcium released by 500 FTUs per kilogram of Natuphos E, given as the manufacturer recommendation. Thus, the available phosphorus from the negative control was formulated at 0.40 for phase 1, 0.30 for phase 2, and 0.25 available phosphorus for phase 3. To the negative control, we also added increasing concentrations of phytase, increasing from 500 FTUs up to 4,000 FTUs per kilogram. Next, we had the positive control, which was formulated with phosphorus at current industry levels. Thus, the positive control had an available phosphorus of 0.55 for phase 1, 0.45 for phase 2, and 0.40 for phase 3. Additionally, we added 2,000 FTUs to the positive control to test a superdose effect when the phosphorus level was adequate in the diet. For the feed manufacturing in this experiment, all ingredients that contain calcium and phosphorus were analyzed prior to formulation so that we could determine the correct nutrient loading of each feed ingredient. We also used the analyzed phytase activity to establish the inclusion level into each of the experimental diets. We then derived all the diets from 8 identical basal batches to reduce the amount of variability that we can see between different batches of feed. We pulled subsamples of bags from each of these batches, used them as the major ingredient into the experimental diets, and then also hand-added treatment-specific ingredients to achieve our final dietary treatments. This table here will show the composition of the basal batch on an as-fed basis. What you'll notice is for phase 1, we have a diet that contains more specialty proteins such as dairy lac and dried whey. And then as we go out to phase 3, you'll notice it becomes a standard corn and soybean meal diet. This next table shows the calculated analysis of the basal batch. It was formulated with an SID lysine of 1.4 for phase 1, 1.35 for phase 2, and 1.25 for phase 3. Additionally, I'd like to note that the available phosphorus in the basal batch was held at that of the negative control, from which we would either add phosphorus through monocalcium phosphate or limestone to increase the calcium and phosphorus concentrations in the diet. This next table shows the formulation of the negative control and the positive control within the 3 dietary phases for this experiment. What you'll notice is that we added limestone and monocalcium phosphate to increase the calcium and phosphorus levels in the positive control. Additionally, sand was added as a non-nutritive ingredient such that the same amount of basal mix could be added between the negative control and the positive control diets. You'll notice we use the same technique for formulation throughout the other 2 phases. Additionally, analyzed crude protein, calcium, and phosphorus were similar to the formulated values. Now, as we take a look at the analyzed phytase concentrations, what you'll notice is that we did have slightly higher analyzed phytase than what we had formulated for. However, they still increased in a stepwise fashion as would be expected. In this study on day 42, or the end, 1 pig per pen was euthanized via captive bolt. From these euthanized pigs, we collected fibulas for percentage bone ash determination. All cartilage caps were removed from the fibulas, and then they were boiled for 60 minutes to remove any adhering tissue. We then dried them in an oven for 7 days prior to being ashed in a muffle furnace at 600 degrees for 24 hours. Total ash weight and percentage bone ash were able to be calculated after that point. For data analysis in this experiment, we used the Prot-Glemix procedure of ASAS and a randomized complete block design. Pen was used as the experimental unit, and barn was used as a random effect. We also used pre-planned contrast statements to determine the linear and quadratic responses to increasing the phytase concentration. Additionally, 3 pairwise comparisons were made in this study. The first was between the positive control and the positive control with the addition of 2,000 FTUs. This was done to test for the superdose effect of when the basal diet is actually adequate in phosphorus. The second was between the negative control plus 500 FTUs of phytase and the positive control, because if you remember back, both were expected to have the same amount of available phosphorus based on the manufacturer's recommendation of available phosphorus release for 500 FTUs of phytase. And then the third was a pairwise comparison between the negative control and the positive control to test the different levels of phosphorus. Significance for this experiment was set at p is less than 0.05 with a marginal significance at p is less than 0.10. Now, as we move on to the results, first let's orient you with the slides. Along the vertical axis, we will have average daily gain in grams and the response criteria for the remaining slides. Along the horizontal axis, we will have the experimental diets. Starting off in purple, we'll have the negative control with the increasing concentrations of phytase, and then the green bars will be the positive control with either 0 or 2,000 FTUs per kilogram of phytase. Now, as we take a look at average daily gain, within the negative control, we observed a tendency for a quadratic response where average daily gain was maximized at 1,000 FTUs with no further improvement thereafter. Now, as we compare the negative control with 0 FTUs and the positive control with 0 FTUs, we observed an improvement in average daily gain when pigs were fed the positive control diet. There were no differences observed between either of the positive control diets. Now, as we take a look for average daily feed intake, within the negative control, there were no differences amongst average daily feed intake. However, as we compare the negative control with 0 inclusion and the positive control with 0 inclusion, those pigs fed the positive control diet consumed more than those pigs that were fed the negative control diet. Additionally, as we compare the negative control with the addition of 500 FTUs of phytase and the positive control that were formulated to have the same amount of available phosphorus release, we observed that the positive control pigs additionally consumed more feed than those on the negative control with the addition of 500 FTUs of phytase. There were no differences observed between feed intake on the positive control. Now, taking a look at feed efficiency, among the negative control, we observed a quadratic increase in feed efficiency that was maximized at 500 FTUs per kilogram, with no further improvement thereafter. Within the positive controls, we observed a tendency for an improvement in feed efficiency with the addition of 2,000 FTUs of phytase to the positive control diet. As we compare the negative control with the addition of 500 and the positive control with no phytase, the feed efficiency on the negative control plus 500 was improved compared to the positive control diets. Now, we also did bone analysis, and so these next slides will show that data. First, we will have fibula ash weight, in this case, grams. We observed both a linear and a quadratic response within the negative control, where increasing phytase in the diet improved the fibula ash weight up to 2,000 FTUs per kilogram. There was no difference in fibula ash weight that was observed between the positive control and positive control with the addition of 2,000 FTUs of phytase. Now, if we compare the negative control with no phytase and the positive control with no phytase, we observe that the positive control pigs had a higher fibula ash weight than the negative control pigs. Finally, as we look at fibula bone ash on a percentage basis, as phytase increased in the negative control diets, we observed a linear increase in fibula bone ash from 44% up to 49%. Additionally, there was a linear increase amongst the positive control, where 0 was at 47%, and adding 2,000 FTUs improved it to 51% bone ash. Finally, when we compare the negative control with 0 FTUs and the positive control with 0 FTUs, the positive control pigs had a higher percentage bone ash compared to those fed the negative control. So, in conclusion, we observed that growth performance was improved as Natuphos E 5000G was increased in concentration up to 1,000 FTUs per kilogram. Because we observed differences in performance between the pigs fed the negative control plus 500 FTUs and the positive control diets, this suggests that the release value for 500 FTUs per kilogram of Natuphos E that was assumed in formulation for this study was a bit overestimated. We also observed marginally improved feed efficiency when 2,000 FTUs per kilogram of phytase was added to the positive control diets considered to be adequate in phosphorus. And finally, bone ash values linearly increased as phytase concentrations increased, regardless of the amount of phosphorus that was in the basal diet. With that, I'd like to thank BASF for their partial support of this project, and thank you for listening.